This lesson is for Advanced Algebra, Lesson 7.7 on Rational Exponents. In Lesson 7.6, the previous lesson, we did work on some rational exponents, and so we're going to do a quick review on that lesson before we dive into this new lesson. Students will need both Baby Calc and a graphing calculator to do this lesson, so make sure both are available before you begin. First, let's just take a look at 16 to the 1/2 power and 16 to the 2nd power. Hopefully students know that raising to the 2nd power means take 16, or the base number, times itself 2 times. So that number is going to get awfully big awfully fast. However, when we contrast that to 16 to the 1/2 power, now we're trying to come up with a number times itself that equals 16. Students are probably used to doing that with a square root symbol. So the goal here today is to try to encourage students to think about taking a 1/2 power and taking the square root, and that those are indeed the same thing. So what number times itself 2 times equals 16? Hopefully students know there that that's a 4. So when you're raising to the 1 over something, that's going to be considered a root problem. And that was what we were supposed to learn last time in 7.6. A root problem, when you have a fraction power like that, is going to turn the base number into a smaller number. When it's just a regular power or a whole number, it's going to turn that base much bigger, much faster. So let's do a few more root problems just to refresh students' memory from 7.6. If you're doing 8 and raising it to the 1/3 power, that's the same as you figuring out the cube root of 8. What number times itself 3 times equals 8? Hopefully students know that that number there is a 2. Similarly, when you take 25 to the 1/2 power, that's just like saying the square root of 25. What number times itself is 25? Students need to know that one. They probably already do. Have that one memorized. That one's a 5. Now be very careful on this last one. 16 to the 1/4 power is like taking the 4th root of 16. You're trying to find a number times itself 4 times that equals 16. Common wrong answer here is for kids to say 4, because students know that 4 times 4 is 16. But a 4 times a 4 would only be 2 numbers, and we need 4 numbers multiplied together. So it's not 4. Remember, we got to do something times something times something times something that equals 16. So it's got to be a number even smaller than 4. So hopefully students know there that that would be a 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So we worked with root problems in lesson 7.6. Notice that a commonality among all of those powers is that they all have a 1 in the numerator. Not all fractions have a 1 in the numerator, however, so that's what we're going to focus on today. So what to do when you have a number other than 1 on the top of a fraction power. So we have something we're going to look at called the rational exponent theorem. When you have a base and you're raising it to a rational power, rational is another word for fraction, the top number of the fraction is going to be considered a power or an exponent, and the bottom number is going to be considered a root. And so what we're going to do is break up that fraction into 2 parts. We're going to pull the root part, pull the power part off or away from the fraction and leave it as a plain number. When we pull that m off, we were going to replace it with a 1 on top of the fraction. So we end up with a 1 over n and an m as 2 separate pieces. Keep in mind that you are simply using a property of powers here. If you had a power of a power, normally kids are used to multiplying there. If you multiply 1 over n times m, you would get m over n, which is what we're starting with. So we're using that property in reverse here. So if we did 1 over n and then multiplied by m, we'd end up with to the m over n power. Keep in mind that you don't have to go in that order. You could do the power first and then the root. So you've got 2 options when you do these. Hopefully you noticed here that I did put circles or stars around root first and then power. Typically that is the faster and easier way to handle rational exponents. Try to do the root first and then do the power. It's not wrong to do it the other way, it's just going to be a lot more difficult. With practice, students should be able to mentally simplify these expressions mentally. What I mean there is with a baby calc only. Not all the questions are going to be baby calc, but most of them are. So here's some examples of what students should be able to do. The first one is a graphing calc question. The rest will be baby calc. The reason why this first one is a graphing calc question should be obvious. If we practice ripping apart this power, or the rational exponent, into a 1/5 first, and then a 3 as a separate piece, you'd be trying to find a number times itself 5 times that equals 25. And we don't have that number memorized. We know a square root of 25, but we don't know a number times itself 5 times that equal 25. So students wouldn't need to do that by hand or on the baby calc. You can literally type it in as it is. So when you type it in on your calculator, you're going to type in 25, use the caret symbol, and then just do 3 divided by 5. And when you do that, you'll get a decimal number. You'd pay attention to what to round to. If they asked you to round to the 10th, you'd end up with a number like 6.9. Those questions will come up very seldomly. Most of the questions students are going to see with simplifying are going to involve a baby calc, and they're going to look like our next 3 examples. When you're asked to take a base and raise it to a rational exponent, you should rip apart the pieces. The top and the bottom become 2 separate parts. When you rip off the 3, a 1 takes its place, and we do the 1/4 first. Then we do the 3 as a power later. It's not wrong to do the 3 first and then the 1/4, it's just going to be a lot more difficult to handle it that way. So we want to figure out the 4th root of 16. What number times itself 4 times equals 16? We just did that one, so hopefully students remember that that's a 2. The more you do these, the more familiar you'll get with them. So 16 to the 1/4 power makes a 2. We still have to raise that to the 3. Don't say 6. 2 to the 3rd is not 6. 2 times 2 times 2 is 8. And so that's our final answer. Let's try another one. 25 to the 3/2 power. Again, let's rip apart the power. When you take the 3 off of the fraction, it gets replaced with a 1 on top. We do the 1 over the 2 first, and then we do the 3 later. 25 to the 1/2 power is the same as taking the square root of 25. What number times itself twice equals 25? Hopefully students know there that that's a 5. We still need to cube that number. Don't say 15. 5 to the 3rd is 5 times 5 times 5, which is 125, not 15. Our last one here is 8 to the 5/3 power. The base stays the same. We're going to take the 5 off of the fraction, which leaves us a 1/3, and then we're going to do the 5 as a separate step. The 3rd root of 8 means what number times itself 3 times equals 8, which hopefully students know is a 2. That's a good one to get memorized right there. And then we still need to do 2 to the 5th. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. The little dashes here were to help you visualize that I was actually using my fingers there to help me count to the 5. So I ended up with a 32 there. So students need to just continue to practice questions like that. The more you do them, the more familiar you'll get with a lot of these root values. Keep in mind that the exponent properties from lessons 7.2 and 7.3 don't disappear here. We can still use those. So if you look at this first example here, we've got 25 to the 1 times 25 to the 1/2. If this were just a 5 times a 5 squared, hopefully students know there that you would, since the bases are the same, you would add the exponents. We're going to do the same thing here, except that we've got a fraction. So we're going to have 25 to the 1 plus 1/2. To add fractions, remember you need a common denominator. So the common denominator here would be 2. 2 divided by itself makes a 1. When we add that to 1/2, we get 3/2. Some students say here that it would be fine just to leave it as 25 to the 1 and 1/2. While that is correct, there is no way for us to simplify that, so it's better for us to write it as an improper fraction. Because now we can do 25 to the 1/2 and then to the 3. We take that 3/2, rip the 3 off, do that later, and deal with the 1/2. So 25 to the 1/2 power is the same as the square root of 25, which is 5. When I cube that, I get 125. So we used the properties of powers first, we used our knowledge of adding fractions, and then we used the rational exponent theorem to simplify. Let's go over here to example F. On this one, if you have a number raised to a power to another power on the outside, you should multiply here. Keep in mind though that the 4/3 needs to be distributed to the 27 and to the x. So there's lots of different things going on in this first question. So I'm going to say 27 to the 4/3. I'll separate those parts of the fraction later. And then I've also got x to the 6th, which is being raised to another power, so those are going to get multiplied together. So I wrote down my first step there, and now I'm going to try to simplify as much as I can. 27 to the 4/3, I'm going to do 27 to the 1/3, and then do the 4 separately. So the cube root of 27 means what number times itself 3 times equals 27? Don't say 9. It's 3 there, and 3 to the 4th is 81. Now I knew that one by heart. If you didn't know that one by heart, you'd want to count it out or figure it out using your baby calculator. Over here, when we do a multiplication of fractions, 6 times 4/3, you do not need to worry about a common denominator, but you might want to stick a 1 under the 6. Multiply straight across. 6 times 4 is 24. 1 times 3 on the bottom is 3, so we get x to the 24 over 3. Luckily, those divide evenly, so I would just get x to the 8th there. And then those two items just sit right next to each other. So we utilized a property to get rid of the parentheses, and then we also used what we know about powers of powers to multiply. You're also going to need to know how to solve using rational exponents. We talked about solving with rational exponents in lesson 7-6, so let's review what you do to both sides when the variable that you're solving for is the base. Hopefully students know there that you should use a reciprocal power. A reciprocal power will allow you to isolate the variable. So on this first question, we're trying to solve for x. There's a 5/4 power in the way, so we're going to raise to the 4/5 power. And we do that on both sides because it's an equation that needs to be balanced. Over here on the left-hand side, when we do x to the 5/4, and then we raise or multiply by the 4/5, notice that again we would multiply the powers together. That's just a property that we learned back in 7-2. 5 times 4 on the top is 20. 4 times 5 on the bottom is also 20. 20 divided by itself is just x. Then on the other side we've got 243 raised to the 4/5 power. So let's break that rational up into 1/5 and then the 4. So a 1/5, that's going to be a pretty big number, or pretty difficult number for us to figure out with just a baby calc. So let's talk it through. First of all, it's an odd number, so I'd probably start with the number 3 and I would do some trial and error. 3 times 3, or 3 squared, is 9. 9 times 3 is 27. 27 times 3, again, I know is 81, because I just did 3 to the 4th here and I knew that it was an 81. So 81 times another 3, let's see if that's 243. 8 times 3 is 24, 1 times 3 is 3, so yes, I do get 243. So I guessed right, my answer there was a 3, even though I didn't know it by heart. So 243 to the 1/5 power is 3. I still have to raise that to the 4. Oh, and I did know that from earlier, 3 to the 4th is 81. So my final number there is 81. And I didn't even need a calculator to figure it out. Let's try it one more time with this last example here. Again, to get the y isolated, we're going to raise to the reciprocal power. So 3/4 gets raised on both sides. On the left-hand side, the fractions will cancel each other out. 625, let's rip that into a 1/4, and the 3 gets done separately. So the 4th root of 625, it ends in a 5, so 5 would be a good guess. Let's check it. 5 cubed, I know, is 125. Let's multiply that by another 5. 5 times 5 is 25. 2 times 5 is 10, carry the 2 is a 12. 1 times 5 is 5, carry the 1 from the 12, I get a 6. So I was right on my guess. So the fourth root of 625 is 5. I still need to cube that, and I already know that that is 125. So that's how you're supposed to solve with using rational exponents. The last thing students need to know is our last example here. You will run into some word problems. Typically for those, you're going to be using a graphing calculator. Read the word problem first and then answer the questions. A formula that gives the approximate volume V of a soap bubble in terms of its surface area is the formula V equals 0.094 A to the 3/2 power. Let's rewrite that just so that the power looks a little bit more like what it's supposed to. So it should be 3/2 like that. The first thing they say is that we should find the volume, V, when the soap bubble has a surface area of 20 centimeters squared. Keep in mind here that the 20 centimeters squared, only the label is being squared, the 20 is not. So the number they're giving us is a surface area, and that's what A stands for. So I'm going to plug 20 in for A. So I take 0.94 times 20 for A, and then that gets raised to the 3/2 power. Literally, you're going to type that in on your calculator just as I wrote it. 0.094 times 20, raise it to the 3 divided by 2. And since this number is rounded to the thousandth, let's do the same here. So when you type that in, I believe you get 8 point something. I think you get 4076. So if we're rounding to the third decimal place, the 6 would tell you to round the 7 up. So we'd say 8.408. Volume should be labeled as centimeters cubed. And we did round it, so we'll use a squiggly equal sign there. Our last question we're going to do here is they say find the surface area this time with a volume of 25. So I fill in a 25 for V this time, and then I write down 0.094 A to the 3/2. We're going to take a few notes along the side here as we solve. We're trying to solve for A, and when we're trying to solve for A, that means we need to get the A isolated. A is currently being multiplied by 0.094, and it's also being raised to a rational power. Remember, when you're solving, you want to work backwards. So normally the power would take priority, but when we're solving, we go the other direction. So I want to make sure that the A gets isolated, or the base gets isolated. So we want to isolate the base before we take the reciprocal power. So that 0.094 needs to get dealt with before I raise to the 2/3. So we're just going to take a quick note there just so you have that as a reference. Isolate the base before using a reciprocal power. A lot of times students get real excited about using that reciprocal power and they do it too soon. So we're going to divide by 0.094 first. And when we do that, we get about 266, I believe. You'll get a decimal on your calculator, so leave that decimal there, because we're going to take whatever we got and we're going to raise it to the reciprocal power. So in this case, we'd raise it to the 2/3. So don't type in 266, do your division, and whatever you get, raise that to the 2/3 power. And you will be using a graphing calculator to do that. You get about 41 there. Make sure you label it, it's for surface area. So we're going to say 41 centimeters squared.